This is video 8. Who did this? I'm going to need to talk to the division chair. Whoever has the classroom before us is supposed to erase the board. Well, while it's here anyway. This was a specific example where numbers everywhere. We could do actual calculations and come up with actual numbers. But that's no good for a program because we don't want it to draw exactly the same rectangles every time. We want to be able to base the rectangles that are drawn on the mouse clicks that the user actually types in. So all this has to go away. But we're going to do the same stuff, but without the numbers. So if numbers scare you, you'll be great. If algebra scares you even more than numbers, then you won't be great. By algebra, I just mean we'll be using some variables and constants to represent stuff. And also, I'm going to need to do a little formula work over here. So I'm going to shift my graphics window. I'll move it on the screen so that it's up here. We'll still have an up and down coordinate. We'll still have a left and right coordinate. I'm going clear over to the edge of the board. Except I'm not, and this will still be 0. I'm not even going to, yeah, I am. I'm going to put 0 there. It's 0 for both of those axes. Except I'm going to parameterize this. Instead of saying that this is 800 or 1,000 or 600, whatever it is, I'm just going to call it width. W-I-D-T-H. And the convention, if you don't remember, the convention is when you set up, even though it's a variable, we don't treat it like a variable. When you set up a value as nothing but capital letters, that means it's untouchable. You set it once. Maybe I'll set width to 800. Maybe I'll set width to 750. But throughout the rest of the program, I only use that in calculations. I do not assign width a new value. I don't read in a new width or anything. I'm going to treat that as if that is constant and unchangeable. Same thing for height. Well, I'm even going to move height because I'm trying to reserve this piece of the board over here for some of the stuff we're going to have to do. Height. Also yield. Height! Okay, and then that will give me, see if I can do as perfect a rectangle as last time. Not exactly, no. But it's maybe good at, I'm going to have to do something with this. No, I'll leave it. Okay. Split it in half. Maybe I'll do the split in half better. Yeah, that's better than last time. And split it in half the up and down direction. Okay. That might not be as good as possible, but that's as good as it's going to get. We're still going to have a rectangle. I can actually start in any quadrant. I can start in any one of these 4. It doesn't matter because the calculations, as it turns out, are going to be exactly the same. All I got to do is I got to get 2 points, and they were roughly here, if I recall, and roughly there. And unroughly, very precisely, we're going to make the Python graphics library draw us a rectangle using those 2 points, which is rectangle A. I'm not even going to put A there. I'm just going to call it rectangle A, but I am going to call this A1, and I am going to call that A2, because I need a way to refer to those. That's the name of the point object, and now, from those 2 points, those 2 mouse clicks that I saved in variables, I can get the X and Y coordinates. I'm not going to make up pretend numbers anymore. I'm just going to leave those abstract. So I'm going to call this A1X. And that's a 1, not an L. A1, because it's point A1. X, because it's the X coordinate. You're way ahead of me. I know you are. The second coordinate is A1Y. Why? Because it's Y. A2, similar, that's not easy to say. Similarly, this will be A, Trout threw me off, he's about back barking. A2X, comma, A2Y. And there you have it. Parameterized coordinates for A1 and A2. And again, those are variables that'll be filled in with the X and Y coordinates that correspond to the points that the user clicks on the graphics window. You got all that? That was fast, wasn't it? For a rectangle, I'll keep up with them one at a time. For rectangle A, we got 2 points, A1, which is, I just now wrote it, A1x and A1y. If we know those 2 points, then we can draw this rectangle. No question. That's a 1. It's an ugly one, but it's a 1. A1x, A1y. This will be better. A2x, A2y. From, where did they come from? From user mouse clicks. No calculation. We do need to use those accessor member functions, those accessor methods, to do the get x, get y, so that we know what A1x, A1y, A2x, A2y, what those are, but there's no calculation involved. We just read the mouse user clicks, or the user mouse clicks, either one. Okay, first calculation, I think it went that direction. So we've got to calculate these 2 points without any numbers. That doesn't look right, does it? There. This will be point B2, because it's a reflection of A2. This will be point B1, because it's a reflection of A1, which allow us to draw, you guessed it, rectangle B. And it's just as easy to come up with the coordinates over there than it was over here. What could be simpler? This will be B2x, comma, B2y. And this will be B1x, B1y. Make those look a little more like ones, a little less like L's. Well, is it as easy? No, because the user didn't click and give us those for free. Unfortunately, we're going to have to do some calculation of our own. It's still going to be that rectangle B has these 2 points at its corners. B1, which is down there. B1x, B1y, and you can get way ahead of me and do B2 while I'm talking about it. B2x, B2y. But I don't get to say from user mouse clicks. I'll do the dots where we've got to have formulas for these things, almost like our temperature formulas. We've got to figure them out. Let me see. What's the easy one? There was an easy one for each one, right? Let's focus on B1. B1, point B1 with a capital B, and point A1 from the capital A are both the same drop-down distance from the top. What does this mean? That means that their y coordinates are the same. So I can calculate B1y very easily. B1 with a y, B1y equals A1y. Of course it does. B1x is the problem. Not a big problem, but it takes a little bit of thinking. B1x is the bounce back, B for bounce. A1x is this far. See how far? That far. About the length of my finger from the wall. B1 needs to be that same distance from that wall. How did we calculate that? Well, we took the width of the entire screen, which is the distance of that wall from this wall, and then subtracted how far from the wall we needed to be. How does that translate into all this? Well, B1x, I go all the way over, which is width, W-I-D-T-H, go that far over, and then I subtract how far I am from the wall over here, minus A1x. I hope I'm not in the way. I think I moved things around a little bit. Now am I out of the way? Here's our formulas. B1y is the same as A1y because they're the same distance from the top. B1x is a little more difficult. Let's see. B1x, I want that to be the same distance from that wall as A1x was from this wall. So I need to go all the way over widthwise and then subtract A1x, and that brings me back to where B1x needs to be. Now you probably picked up on it in the last video, but once we get the formulas to calculate what B1 needs to be, it's going to be the same thing here. Calculating the reflection of a point this direction horizontally, it's going to be the same 2 formulas no matter what. So without even thinking about it and talking about it, I'm just going to write these down. These two are for B1. Here's for B2. B2y equals A2y. B2x equals width minus A2x. Now I'm getting nervous. I don't trust myself. Let me see. B2y equals A2y. B2y is how far B2 is from the top, and it's got to be the same distance from the top as A is, which is A2y. So check. Check, please. What about B2x? B2x needs to be the same distance from that wall as A2 was from this wall. So I go all the way over. If this distance right here, I just can't help it. Let's just pretend that that's 100. Pretend. Then all the way over and back 100 is going to be width minus 100. Width minus this distance will give me how far B2x needs to be to get it in the right position for the reflection. I didn't end that sentence very well, I'm sorry. B2x equals width minus A2x. I hope I've done this right. You know what? This is the first video that I am really nervous about that I'm going to have to go back and review before I upload it. So there might be a bit of a delay. We ask that you bear with us. Okay. Assuming that that's correct, double check, double check. I got to reflect this direction too. This will be point C1 because there's reflection downward of A1. Now I'm reflecting about the horizontal axis. And this will be point C2. Also reflected about the horizontal axis to give me rectangle C. And rectangle C has these 2 points at the corners that we'll have to send to the rectangle constructor. C1, getting nervous about board space here too. C1 has these coordinates. C1x, C1y. C1x, C1y. C2 has these coordinates. C2x, C2y. C2. C2x, C2y. Those variable names are getting kind of complicated, aren't they? I don't really know a shorter way to do it that pulls them all together so you can see how they're related. We need a where. Where? Okay, step out and identify yourself. Who are the easy coordinates here? It looks like the x coordinates are going to be the easy ones because the x coordinates tell me how far away I am from this wall, the vertical wall, and that needs to be the same. C1's x coordinates got to be the same as the a coordinate. So this will be where C1x equals A1x. And I almost went ahead and wrote the C coordinates for that. I want to go ahead and polish off the coordinates for C1 first. C1x is the easy one. C1y equals C1y. How far down am I from the top? Well, it's as if I went all the way to the bottom and then bounced up that high. So if I go all the way to the bottom, that will be height, the full height. And then I bounce up. I come back up this direction. How far up do I need to come for C1y? Well, I need to come the same distance that I move down this direction. I move down this direction, A1y. That's what got me. This is A1x. Going across that way. This picture's already hopelessly messed up anyway. I might as well trash it. A1x is how far I went over to get to this point. A1y is how far down I went to get to that. So if I've got to go down A1y to get to A1, I've got to go up A1y to get to C1. I'm not going to call it A1y down here. I'm going to bounce it off the height and take the height and subtract A1y. It looks like Ellie. Can't let that stand. Sorry. There. A1x. All those things that look like L's are 1s. Okay, so the height minus A1y. Bounce up this, whatever that distance is, will get me back up where I need to be for the C coordinate. And the same thing here for C2. Those are the coordinates for C1. Coordinates for C2, I should be able to just knock them out here. Let's see. C2x equals A2x. C2y equals height minus no, A2y. Oh, good heavens, I'm going to have to review this. Make sure you won't see this unless I've reviewed it. It comes with my later self, the self me of the future, seal of approval. Let's see. C2x is A2x. Do I even believe that's true? C2x is how far over. A2x is how far over that point is. Okay. Height minus A2y, C2y. Height, the whole thing, minus A2y. Well, that's not very far. Okay, but I've subtract that from height. It doesn't bring me back up very far. But that's what I want for C2y. So here are the coordinates of C2. C2x, C2y, and here's how you get them. And of course, mystery. Mystery D. How am I going to calculate those coordinates? Well, that's an easy question for me to answer. I'm not. You are. Calculate those coordinates for that rectangle D. Get that to show up in the right place. That's part of your job. In terms of Project 3 geometry, oh, I didn't say what this was. This is generalized. Generalized. And generalized, here's a box for you to check. Generalized is now. Check. Done. And that should be the coordinate geometry stuff you need for Project 2. That looks pretty complicated when you step back and take a look, doesn't it? It's not. You go through it one step at a time. Watch this video in slow motion or something, and you'll be fine. Take my word for it, and I'll see you online.